Welcome to another episode of Operations Matters. I'm Dr. Martin Lockström, Executive Director of International Institute of Operations Management. In today's episode, we're going to talk about process management. Let's dive in. Processes, in the most fundamental sense, signify systematic series of actions or steps taken in order to achieve a particular end. Whether in the natural world or in the constructed environment of organizations, processes are the backbone that defines the flow of activities. It is positioned at the core level as part of the House of Operations Management framework. The concept of a process takes on a more structured form, often referred to as a business process. A business process can be understood as a collection of linked tasks which find their end in the delivery of a service or product to a client. It is a blueprint that outlines how daily operations are conducted within an organization. Davenport in 1993 characterized business processes as structured, measured sets of activities designed to produce a specified output for a particular customer or market. This implies a strong emphasis on how work is done within an organization, in contrast to a product-focused emphasis on what is produced. Process at its core denotes a sequence of activities designed to transform a set of inputs into desired outputs. These activities are often systematic and repeatable, aiming to achieve a specified outcome with optimal efficiency and effectiveness. Examples of business processes are as follows. Procurement process. This is a method businesses use to acquire resources. It begins with identifying a need, proceeds with selecting suppliers, negotiating prices, and ends with receiving the required goods or services. The aim is to obtain high-quality resources at the lowest possible cost. Sales and order processes. This involves receiving and processing customer orders. Steps typically include order receipt, entry into a system, order confirmation, production or dispatching of goods or services, invoicing, and receiving payment. Fourth, manufacturing processes. This is pertinent to business involved in production. It details the steps required to convert raw materials into finished goods, ensuring quality control, proper utilization of machinery, and efficient production techniques. Fifth, human resource management process. From hiring to training, performance assessment, and even separation, human resource management or HRM process. From hiring to training, performance assessment, and even separation, the HRM process outlines the various stages involved in managing an organization's workforce. The goal is to optimize the performance of the employees in line with the organization's strategic objectives. 6. Customer service process. From handling inquiries to complaints and feedback, this process ensures that customers' interactions with the organizations are streamlined, effective, and satisfactory. Business processes are integral to the effective and efficient functioning of an organization. They provide structure, clarity, direction for organizational activities, ensuring that resources are used optimally and objectives are met. By understanding, optimizing, and periodically reviewing these processes, businesses can achieve better outcomes, satisfy their stakeholders, and thrive in competitive environments. In the realm of operations management and manufacturing, the concepts of process planning and process control hold pivotal importance. Both processes, while closely related, serve as distinct functions within an organization. To understand these functions thoroughly, one must delve into the nuances and intricacies of each. Process planning can be described as a systematic approach to delineating how a product will be manufactured or how a service will be delivered. This involves defining the specific processes, sequence of operations, and resources, like tools, machinery, and labor, necessary to transform materials or inputs into finished goods or services. Essentially, process planning acts as a blueprint or roadmap, guiding the production process from conception to completion. Components of process planning are as follows. First, selection processes. Identifying the best processes suited for producing a particular product or service based on factors like production volume, product design, and available resources. Second, determination of sequence. This involves specifying the order in which the selected processes will be executed to ensure efficient production. Third, resource allocation. Designing appropriate tools, machinery, and labor for each stage of the production process. Fifth, process control. An elucidation contrary to process planning, which centers on the preparatory phase of production. Process control is entrenched in the monitoring and management of actual production activities. Process control ensures that production operations remain within specified limits, guaranteeing that the output aligns with the desired quality standards. It encompasses continuous oversight, measurement, and potential adjustment to ensure processes yield the desired outcomes. Key components of process control are as follows. First, monitoring. This involves regularly observing and tracking the progress of production processes to ensure they align with the plan. Second, measurement. This involves utilizing tools and techniques to measure output quality and process efficiency. Third, feedback and adjustments. Based on the insights gathered from monitoring and measurement, process control may necessitate making adjustments to achieve desired outcomes. Differences between production process planning and control. At a glance, process planning and control might seem intertwined, but a deeper examination reveals some notable difference. First is a temporal placement. Process planning is predominantly a preparatory activity, undertaking before actual production begins. In contrast, process control is an ongoing activity occurring concurrently with production operations. While process planning is concerned with determining the how of production, laying out steps, sequences, and resource allocation, process control is preoccupied with ensuring that these delineated steps are executed effectively and efficiently, yielding the desired quality of output. The success of process planning is gauged by how well the plan aligns with organizational capabilities and objectives. Conversely, the efficacy of process control is measured by the consistency, quality, and efficiency of the actual production output. In conclusion, to encapsulate, process planning and process control are complementary yet distinct facets of operations management. Process planning focuses on the strategic delineation of the production roadmap, whereas process control emphasizes the tactical implementation and monitoring of this roadmap. Both are integral to ensuring an organization's operations are both effective and efficient, thus cementing their foundational impact and importance in the landscape of production and service delivery. Processes integral to both manufacturing and service industries constitute the backbone of operations management. Delving into their core discerns a variety of elements, processes, linkages, and buffers that collectively define the function and flow of operations. Through meticulous examination, we can grasp how processes intertwine, form networks, converge, diverge, judiciously apply resources, thus ensuring efficient outcomes. Linkages refer to the connections of relationships between different processes or stages within a single process. In many operational scenarios, outputs from one process become inputs for another, creating a chain of interdependent activities. Properly managed linkages ensure smooth transition and reduce interruption or delays, thus promoting a seamless flow of operations. Key aspects of linkages are as follows. First, interdependencies. Linkages signify the interdependence between processes where the output of one process serves as input for another. Effective coordination between linked processes is crucial to avoid bottlenecks and ensure efficient resource allocation. Linkages facilitate the flow of information between processes, enabling real-time decision-making and adjustments as needed. Balancing supply and demand buffers, often manifested as inventory in manufacturing context, play a pivotal role in operations management. They act as reserves or cushions between processes or stages, absorbing fluctuations in demand or supply to maintain operational stability. Buffers are strategic tools that help organizations manage uncertainties and optimize utilization. Buffers also mitigate the impact of demand variability by absorbing surges or dips, ensuring a more stable production or service delivery process. In supply chain management, buffers like safety stock protect against disruptions, ensuring continuity even in the face of supply chain uncertainties. Buffers also provide organizations with the flexibility to adjust production levels or respond to unexpected events without disrupting the entire workflow. Interconnected operations in complex operational environments, processes form intricate networks that span departments, functions, or even external stakeholders. These networks reflect the interplay between various activities, resources, and information flows, shaping the overall efficiency and effectiveness of operations. Process networks integrate diverse activities and functions, aligning them toward common organizational goals. Managing interconnected processes require effective coordination to ensure seamless operations and prevent bottlenecks. Well-designed processes also exhibit scalability, allowing organizations to adapt to changing demands or scale operations as needed. Efficiency through optimization, converging, and diverging processes are strategies employed to optimize operations and resource utilization. Resource allocation is a cornerstone of operations management, ensuring that resources such as labor, machinery, and capital are deployed optimally to support organizational objectives. Resource application encompasses strategies for allocating, managing, and optimizing resources across various processes and activities. Matching production capacity with demand to avoid underutilization or overutilization of resources. Leveraging technology to enhance resource efficiency, automate tasks, and improve decision-making processes. Adopting lean principles such as just-in-time or JIT inventory, waste reduction, and continuous improvement to optimize resource utilization. Orchestrating operations inputs, outputs, and the information flow forms the lifeblood of operations, representing the raw materials, finished products, and communication channels that underpin organizational activities. Understanding and optimizing these flows are crucial for enhancing operational efficiency, quality, and responsiveness. Despite its benefits, optimizing process flow faces challenges such as variability in demand or supply, process complexity, and the need for flexibility to adapt to changing market conditions. Takt time. Understanding takt time and implementing process balancing strategies can enhance operational efficiency and effectiveness. Takt time is a foundational concept in lean manufacturing, representing the rate at which products must be produced to match customer demand. It serves as a pacing mechanism, ensuring that production activities align with market requirements, thereby minimizing overproduction or underproduction. Takt time is calculated as the available production time divided by customer demand, providing a target production rate to meet customer needs. Takt time enables efficient resource allocation, synchronizes production activities, and supports just-in-time manufacturing principles. By setting a standard production pace, takt time promotes operational stability, reduces variability, and facilitates continuous flow production. Implementing takt time has several operational implications, including demand alignment. Here, takt time ensures that production rates align with customer demand, avoiding overproduction or underproduction. Resource optimization. Matching production pace with demand optimizes resource utilization, reduces waste, and improves efficiency. Workforce efficiency. Takt time also provides a clear target for production teams, promoting efficient workflow and task prioritization. Third, process balancing is a strategic allocation of resources and tasks to ensure that production processes operate smoothly without bottlenecks or idle time. It involves analyzing workloads, identifying constraints, and redistributing tasks to achieve optimal flow and efficiency. Assessing the distribution of tasks and resources across production process to identify imbalances and bottlenecks. In conclusion, takt time and process balancing are instrumental in achieving operational excellence, particularly in lean production environments. Takt time aligns production rates with customer demand, while process balancing optimizes workflows to minimize waste and maximize efficiency. By integrating these concepts into operations management strategies, organizations can enhance competitiveness, improve customer satisfaction, and drive sustainable growth. For more information on this topic, please refer to Chapter 7 in our textbook, The Operations Management Bible, available for purchase on our website. A link will follow at the end of this video. Also, if you're interested in accelerating your career toward a C-suite, regardless of whether you're working directly in operations or not, I suggest that you also check out our world-class certification program on our website. If you found this video useful, please subscribe to our channel, hit the notification bell, and continue the journey toward operational excellence in the next video. Until then, take care and bye bye.